So today we're going to talk about the discriminant. And the discriminant happens to be what is underneath the radical. It's the b squared minus 4ac. So back in the day, when I didn't have a calculator, we relied on the discriminant to give us some clues about our parabola as we went about graphing it. So let's just jump into what it means. So b squared minus 4ac is underneath the square root sign, and we know there's definitely some things that we can and can't do with numbers when we go to take the square root of them. So you can see here that I have three cases, actually four, because this number 3 over here is in red and black. So let's go on to talk about them. If you're doing the quadratic formula, or even if you don't want to do the quadratic formula, even if you want to complete the square, you can always do the b squared minus 4ac, and it's going to give you a clue about what your final answer should be like. So if you perform b squared minus 4ac and you get a number less than 0, your ears should perk, right? That means your roots are imaginary. They're not real because you can't take the square root of a negative number, and that's what less than 0 is. So now I know that when I go to graph, my parabola is not going to touch or even cross the x-axis in any possible way. And over here, number 1, we see an example of what it would look like, right? It's hanging up above the x-axis, or it could be below the x-axis inverted. Okay, next step. How about when b squared minus 4ac equals 0? Well, when it equals 0, that's case number 2 over here. So actually, why don't we do this? Let's call this number 1, and we'll call this number 2. So when b squared minus 4ac equals 0, the roots are equal. What do you mean the roots are equal? Well, that means it was basically a perfectly square binomial. So the parabola is only going to touch the x-axis exactly once. It's going to kiss it. So here we have like mama. Mama only crosses the x-axis right here at 0, 0. So she only has one root. We're going to give you more of what I mean on the next page. Then we get down to cases number 3, and we'll call this one 4. All right, so I came over here in case number 3, and I separated them. So what happens when b squared minus 4ac is a perfect square other than 0? Now, let's also, we are talking about anything that's greater than 0. We're talking about positive numbers here, right? We got rid of our negative numbers up here in case 1. So when we get a perfect square other than 0, like a 4, a 9, 256, 81, we like that. We can take the square root of it and we make our life happy. And that means there are 2 unequal roots that are real and rational. So right here, case number 3, in red, 1, 2, 3, 4. We see our roots are 4, 5, 6, and 7. 4 and 7, what are they? They're beautiful roots. Oh, we love it. Right? We got an axis of symmetry, and basically this means that the distance from our axis of symmetry is a nice number that we can count. So that parabola is going to cross the x-axis exactly twice. How about when b squared minus 4ac is a non-perfect square? And once again, that means it's greater than 0. We're not talking about imaginary non-perfect squares. We're talking about real non-perfect squares. Well, that's this other case 3 here. And why I have them both as case 3, I know I said this was 4 over here, is because they cross the x-axis twice. One crosses the x-axis at numbers we like that are rational, and the other ones cross them at irrationals. So if I were to take number 3 and drag it up here, we'd be crossing at points that were probably irrational. Like this is negative 3 point we don't know what, and this is positive 1 point something something. So in that case, we still have 2 unequal roots that are real and irrational. So notice the difference between the 2. They're really the same thing, except one says irrational and one says rational. And guess what? the parabola is still going to cross the x-axis exactly twice. All right, so basically if we were just to play with this, if I just wanted to do the discriminant, right? The discriminant is we take the a value, the b value, and the c value, and we just do the b squared minus 4ac. Okay, so when I take the discriminant of this one, we get b squared is 25 minus 4 times a times c. So that means 25 minus 32. Hey, I'm going to stop right there. I know that this is going to be a number less than 0. So why do I have to go even any further? So a discriminant really just discriminates, tells us about the root. So in this case, I know before I even go to graph it, the roots are imaginary, non-real. So when I do go to graph it, as I have over here, there, that's what it looks like. See, it doesn't cross the x-axis at all. All right, going down to the next one. If I quickly do the discriminant, b squared, 25, minus 4 times a times c. All right, what do I get here? Well, that's 8, that's 56, but that's going to be a plus 56. All right, so I've got to go because I got to figure it out. Is it a perfect square? Well, 5, that's 11. That's 7, that's 81. It's a perfect square. So my roots, my discriminant is 81, which is a perfect square. I can take the square root of it. So my roots are 2 roots. They will be different, so they will be unequal, and they're going to be rational. That means they're going to cross the x-axis at pretty numbers. So let's see what that graph looks like. And there you go. You can see I actually clicked on Desmos, and I saw that this root was -1, and the other root was 3.5. All right, so I have 2 roots. They are unequal, and they're rational. They're numbers that make sense. Moving on to the next one. If I take the discriminant of this one, I get b squared minus 4 times a times c. Well, that's 36 minus 36, so my discriminant equals 0. All right, so that was that one I was talking about. When it equals 0, there is 1 root. So sometimes we say technically there are 2 roots, right? Because it's raised to the second power. We're going to do more about that in the next chapter. 2 roots that are equal and rational. Now, when I take a graph, that's what it looks like. And I know I forgot to tell you what that was on Desmos, but that is the root 3, 0. Why? Because we can factor that. That becomes x minus 3 times x minus 3. And when we set it equal 0 to find the roots, see, there are 2 roots and they just happen to be 3. So I know I really shouldn't say there is 1 root. It really should be there are 2 roots that are equal and rational. So let's kind of cross that out right there. In the last case, b squared, -1 squared is 1, minus 4 times a times c. Well, that turns out to be the number 37. Because, right, we're going to really add there. And I can't take the square root of 37. So I know I'm going to have two roots that are unequal and are real and irrational. So when I look at the picture of what this would graph, and you can see right there are two roots, negative 1.243 and 7.243. They're unequal. They are real numbers, but they happen to be irrational numbers. So in a nutshell, discriminant just helps us decide what the picture should look like ahead of time. And it really describes the roots. Like I describe you guys to people. They're tall, they have dark hair, they have long hair, they have short hair, but they have blue eyes. Well, the roots of a quadratic really can't be that much. They can be real roots. That's when the square root is 0 or above. They can be non-real. That's when the number inside the square root is negative. They can be irrational or rational, depending on whether we can take the square root of the discriminant. Then they can be equal or non-equal. And these are the words you need to use when they ask you to describe the roots based on the discriminant.